Welcome back to another M&S tutoring video, and today we'll be learning how to optimize a cylinder. In our previous video we learned how to optimize a rectangle, but now we are going to be optimizing for surface area and volume rather than area and perimeter. So let's get started. We're going to start with optimizing the volume, which we're trying to max the volume given a set surface area. For this, you have to remember that the dimensions to get the maximum volume, you have to have the height is equal to 2 times the radius. This is just a set dimension you have to use to find the max volume when given the surface area of a cylinder. So let's look at the surface area formula for a cylinder. The surface area formula is pi r squared plus 2 pi r times h plus pi r squared, right? Now that we know that h is equal to 2 times r, we can sub in h for 2r, and we can reword the formula to be SA, which is the surface area, is equal to pi r squared plus 2 pi r times 2r instead of h plus pi r squared, right? Now when we simplify this, we get the surface area is equal to 6 pi r squared. This means that this formula right over here will maximize the volume. So when you're given, say for example, you're given the surface area of a cylinder to be, for example, 14 centimeter squared. Say this is the surface area. Now, to find the maximum volume, all you have to do is plug 14 centimeter squares into this surface area formula. You have to plug it into this formula over here, and you have to solve for r. So when we do that right now, we can solve for r to get 14 centimeters squared divided by 6 pi is equal to r squared. And when we simplify that even further, we get 114 divided by 6 times pi. We get 0.7427, and when we square root that, we get 0.86 approximately. So we know that for the radius, so we know that to maximize the volume, the radius of this cylinder has to be 0.8618 approximately. It has to be that much centimeters to maximize the volume. And now all you have to do is plug in this radius into the volume formula to get the maximized volume when given the surface area of 14 centimeters squared. So basically the main formula you have to remember when finding the maximum volume given the surface area is equal to 6 pi r squared. And after you have solved for r, you basically just plug it into the volume formula and you find the optimal volume. So now let's try to find the minimum surface area given the volume. So we're going to use the same method to find a simple formula. We're going to use the volume formula instead of the surface area formula. So the volume formula of a cylinder is V is equal to pi r squared times height. But we know that to maximize either the surface area or the volume, to get the optimal surface area or the volume, we have to remember 2r is equal to h, right? So we substitute h for 2r. So V is equal to pi r squared times 2r, which gives us, when we simplify it, 2r pi, or 2 pi r cubed, right? R is cubed. So this would be a simplified version of the formula. Or if we want to simplify even more, we could simply just write 3 to the square root of V over 2 pi, right? Well, that doesn't really make sense. We can just solve from r using this formula over here. And when we plug in r back into the surface area formula, we can get the minimum surface area. So it kind of works in like a really nice bow, as after we solve for one thing, we can just use the other formula to get the answer we needed. So that's the end of the video, guys. I hope you learned something new about how to optimize both the volume and the surface area of a cylinder. If you have any comments or concerns, please feel free to leave down in the comments below. And thanks for watching, guys.